Hello everyone. In this video we'll look at improving our error messages to take into account what the user entered. We'll also look to encode those into our domain. I'm your host Sam with codingwithsam.com. Let's have a quick recap of where we got to last time. We have the app open here. It's our simple square root calculator app. So we enter a number and we get the square root. If we try and crash the program by entering some bad data, we can enter some text. We get just a simple error, not really explaining why the error happened. And if we also enter a negative number, get some funny text as well. So let's go ahead to our program. Here's where we got to from last time. It's the code. Most of the calculations are done on this calculate function. So in order to take into account the user error, let's focus on this try float here. When we try and convert the string into a float, if we look at the function here, we're just ignoring the actual text that the user input and we're returning nothing back. So we don't crash, but we're also not taking into account what the user really entered to give them a clear message. To improve this, instead of using the option type, which we're returning here, we'll look at using the result type. The result type is very, very similar to the option type. It still has a happy branch and can take any type. But the result type also has a separate branch for the error case, and that can take any type as well. So let's get started. The happy path result type takes an OK, and for the unhappy branch takes an error. And I'll just put a simple string type in for now. So there we go, that's done. That now uses the result type, and we can see here it returns a float of a string, a result. So now we'll use that, and we can see that we've also incurred an error down the bottom here. So to use it a little bit further, we just need to update that to use the result type here. And now the error has been pushed down a bit further. We can get rid of this error because now we can use just a little bit of pattern matching to solve this problem. So I'm going to pipe it into function, and then we'll either get the OK branch, and in this case we'll just update our entry with that value, or we'll get the error branch, and again we'll just update that entry, and we don't need this last line anymore. So everything looks fine now, that all works. The next step is to fix up our square root function. So currently this calculates a square root, but it doesn't handle negative numbers very well. The strategy to fix this is the same as last time. Create a local helper function, and we'll just capture the notion of failure inside that. So again, try square root, takes in some value, and in this case I'm just going to explicitly pattern match on that. X when x is less than 0. Then we want to return an error, cannot square root negative number, go. And for all other cases, we're just going to do the happy path, so math.square root of the value. If you do see an error here, be sure that you use the float value of 0. If you don't, what will happen is FSharp will infer the type to be an integer because it can see the comparison here. And so this will throw an error here saying it can't convert a float to an int. A little period after that tells FSharp this is a float value, so everything will be fine. In order to update this, I'm just going to copy this value here, and we'll just update this to be try square root. And now we can just make this the toString function because we've replaced our square root. Unfortunately though, we now see an error in our result.map toString. And what this means is, the last line is the key part here. It was expecting a float, but it got a result float string. What we've done by updating try square root is instead of previously just returning a float, now we're returning a result as well. So in our happy branch, we've got nested result types. The fix to this is actually quite easy. We can just change our map type to the bind function, and all the problems go away. We can see the type of our bind function here. The binder takes a t to result, and then it decouples and takes apart the result type and puts the correct items on the correct branch. So that all looks good. Unfortunately, we still haven't used our input yet, so we need to update each of these to take into account the input. So for here, we can say printf, and then we can say cannot convert s to a number, and then we can put the value of x on there. So now we've got an error message that actually takes into account the user input. We can do the same here, cannot convert square root of negative number, and let's just put that value on the end there, the float. And of course we have to make that a string, so sprintf. So now this looks much better. Let's give it a quick run and check that we've fixed all those problems. The app has started up. We'll check the happy path first, make sure we haven't broken anything. That looks fine. So let's try the error. There we go. We can see that cannot convert hello to a number. So it's taken our input and given us a much better result error there. And finally we'll try the negative number. Again, cannot convert square root negative number, -9. It's not the world's best error message, but it's certainly much better than what we had before. So this is a step in the right direction. For a real-world application, we could take this a little bit further. This will lead us down the right path. So the last part to this video is just to clean this up a little bit more. We've got the error messages here, but it would be nice if we captured those into our type system. So in order to do that, I'm going to create a type. And this is going to capture the types of errors. So I'm going to title it error. And for one part we've got not a number, and that takes in a type of a string. And for the second part we've got a negative number, and that'll be a float. And so now we can go ahead and we can update this error branch to capture that. So for our not a number branch, wrap that in here. Just put that in, and we can just pass in our value of the original input. And we can do the same for down here. We can already see, we haven't even updated this, we can already see the compiler working for us, figuring out what these types should be and telling us that we've got problems here. So it's almost impossible to get this wrong. And again, we can just pass the input here. And now we can see that we've got most things lined up, so we got rid of the error here. We've still got this last error here. And what this is telling us is that it's saying, well, I can't convert an error to a string. Update entry obviously takes a string, but now we've told that the output here of the result branch is the error type. So I can't convert that. The fix again is another local function. So we can go to string of an error, take in some value, and again we can just explicitly pattern match on that. So allow it to be a negative number, some value, or it will be not a string. Not a number, there we go. And in this case I'm just going to take the values that I had here. So in this case the negative number and the not a number cases. We can now clear these out. So there we go, we've moved all the error handling or the string conversion to one local function. This is nice. And we now just need to use that. So result has a function map error. So this will take and convert the error branch only. So once we apply that, and then we give it the function toString error, you can now see that everything has been resolved. So the code compiles now. The last part that I just as a minor detail, if you like prefer the syntax, is we can use the negative pipe operator to remove the parentheses there. There we go, we've now got our types encoded into the domain, and we're handling that nicely here, so everything's cleaned up. Before we run this, I'll do one last style change here. So this function here, we can actually take that out and put that into the result type. What we can do is we can use the module. If we type in result, then it'll add it in. So f of g, and what we can do is if we've got OK, then we can apply that to the happy path. Otherwise, we'll have some value. We can apply that to the unhappy path. So by declaring the module, it'll then get updated to the result type, and now we can go result.iter, and in this case we want to update the entry on both cases. And that's just a style thing to keep things looking nice down the bottom here. You don't have to do that. Let's run this and check that everything is working. So a happy path first, run that, looks to be good. Let's try our unhappy path. Again, that's capturing the notion of the input there and telling us why it failed. And finally, our negative number. Excellent, that's captured that nicely. So there we go, we've now got our error handling improved by a lot. We've got the input taken into account that the user entered, and we've also got all our failure cases documented in our type system with one function that converts all the error types to a readable string message for the user. Again, you can imagine that in a larger application, this function here can be handled localization or many other strategies depending on how you want to show your error messages. That's all for today. Thank you for watching. Leave a comment if you enjoyed. I'm your host Sam with codingwithsam.com.